Hi everyone, welcome back to chemistry. So this will be our last video for chapter 10. And I want to think back to our first video, which was about Arrhenius acids and bases. And we talked about how Arrhenius's definition of acids is that they increase the concentration of H+. Remember that these brackets mean concentration. He also said that bases increase the concentration of OH-. But how does the concentration of H+ relate to acids and bases? Or in other words, at what point does something have enough H+ concentration to be called an acid, or enough OH- concentration to be called a base? So for acids, the concentration of H+ is greater than 1.0 times 10 to the negative 7 molar. Remember that big M is molarity. And then for bases, the concentration of OH- is greater than 1.0 times 10 to the minus 7 molar. And all of this relates to the pH scale. So one of the ways that we can measure the strength of an acid or base solution, or how much acid or base is, concentrated in our solution, is the pH scale. And this is based on the concentration of the hydronium ion, right, H3O+. Or you could also think of it as H+, right, just those protons, in aqueous solution. Now, I want to talk about these equations, but first I want to look at the pH scale. So the pH scale goes from, you'll see, 0 to 14, where 0 is extremely acidic, the most acidic you can get, and 14 is the most basic you can get. And then right in the middle of 0 and 14 is 7, and that means the substance you have is neutral. So the closer you are to 7 on either end of this scale, the closer you are to being neutral. The lower your pH, the more acidic. And the higher your pH, the more basic. So over here we have some examples of different products or things we're familiar with. And you can see that right in the middle at 7 is pure water. So pure water meaning, deionized water, DI water, something that, not tap water because tap water has some other minerals dissolved in it and stuff like that. But water as just H2O has a neutral pH. It's right in the middle there. Something like coffee is pretty acidic, right? It's got a pH of 5. Something like soda, very acidic, pH of 3. Lemon juice, even more acidic, right? And then very close to the end there, we've got hydrochloric acid. Other end of the spectrum, we've got, basic things. So something like detergent is a pretty basic household product. Or soap. Or household bleach is very basic. A lot of cleaning agents you'll see are very basic. And then sodium hydroxide, or NaOH, right? We talked about how that was a common base. That's also very basic. So going from, a pH of 6 to 7 may not seem like a lot, but this is actually a logarithmic scale. So every increase of pH value of just 1 is a 10-fold increase. So a 6 pH is 10 times lower than a 7 pH, which is 10 times lower than an 8 pH or 9 pH, right? So it increases by factors of 10 as you go up the pH scale. So a small change in pH, can seem like nothing, but it actually is quite a big change. Okay, so now I want to go back to our equations here. So it turns out that we can calculate the pH of a solution using the concentration of H+, or you could think of it as H3O+, right? Those mean the same thing. The concentration of the H+ or H3O+ in solution, which directly correlates to the acidity of our solution, right? The more H+ concentration, the more hydrogen ions you have in solution, the more acidic you are. And this equation is pH equals the negative log of H+, the concentration of hydrogen ions in your solution. Now, you can plug that whole thing into your calculator, right? So you take the negative log of the H+ concentration, and you'll get out a pH value between 0 and 14. So let's try this out, and you'll need your calculator with you to do this. So on this chart, we want to fill this out, and on the left, we've got our concentration of hydrogen ions or hydronium in solution, and we want to know what is the pH, right, using our equation here, and is it an acid or a base? All right, so for the first one, our concentration is 0.1 molar. So pH, we'll just do these calculations down here. So pH equals the negative log of our H plus concentration, which in this case is 0.1. So you're going to plug that into your calculator, and you'll get out a pH value of 1. So our pH for an H plus concentration of 0.1 molar is 1. So using our chart up here, is a pH of 1 acidic, basic, or neutral? Well, it's all the way down here. It's a very low pH value, so that's going to translate to acidic. So this one's going to be an acid. All right, let's try our next one here. So we'll just do this down below, and we've got pH equals the negative log of our H plus concentration, which in this case is 2.4 times 10 to the negative 12. So we'll plug that into our calculator, and you get a pH of around 12. All right, is that an acid or a base? Let's check. 12, let's get rid of these notes here. 12 is all the way up here, so that's going to be basic, right? Anything above 7 is considered basic, and anything below 7 is acidic. Okay, so this one's going to be a base. All right, what about 4.6 times 10 to the negative 4? Let's try that down here. pH equals the negative log of our H plus concentration, which is 4.6 times 10 to the negative 4. So we'll plug that into our calculator. Negative log 4.6 times 10 to the negative 4. And that's going to be a pH of around 3.3. We'll just round that to 3. So a pH of 3, is that acidic, basic, or neutral? Yeah, that's an acid. Less than 7. All right, and then the last one, we've got pH equals the negative log of 9.1 times 10 to the minus 8. And that's going to give us a pH of 7. So that one's actually neutral. And I didn't give you the option for neutral, but it's an option as well. So that one is going to be neutral. Now, what if you got a pH of 7.1? Would that be acidic, basic, or neutral? Yeah, 7.1 is going to be basic, right? 6.9 is going to be acidic, right? Unless you are exactly at 7, you could say you're basic or acidic, right? Just be very slightly basic or acidic. All right, I hope that makes sense. If it didn't, as always, come see me in office hours, email me, we can set up another time, etc. And take care.